Hello and welcome to this tutorial on training neural network with TensorFlow and Keras. And this tutorial, we will explore how to build and train neural network using the powerful TensorFlow and Keras libraries in Python. Neural networks have revolutionized the field of machine learning, allowing us to solve complex tasks ranging from image and speech recognition to natural language processing and much more. Today, we will demystify the basics of neural networks and provide you with practical insights on how to leverage the TensorFlow and Keras frameworks to create your very own deep learning models. Training a neural network in Python with TensorFlow involves several steps. Here's a basic guide on how to do it. The first is install the TensorFlow if you haven't already installed on your Jupyter notebook. So you can install this using pip install TensorFlow. Keras is already built on top of the TensorFlow as an API of TensorFlow, so you don't need to separately install it on your Jupyter notebook. By the way, if you are using Google Colab, so you don't need to install TensorFlow on Google Colab because it supports by default. Then the next step is import the necessary libraries. This is essential. So in the beginning of your code, you have to import all the necessary libraries for your project. So here I imported NumPy, TensorFlow, and the layers and models classes from TensorFlow.Keras API to build the neural network layers. The third step is prepare your data. This is the most and essential step in TensorFlow. So on this example, I just prepare the demi data and just randomly generates 800 samples, each with 10 features and binary labels that are going to train the model as a training or target feature. Target variable. So it's going to be these 800 samples of binary features. And also generate the validation dataset and test dataset. That is very important for training your neural network. So once you prepare the data, you can go to the fourth step. So you can follow all steps and you can implement your own dataset in this training neural network model. Then the fourth step is about build your neural network model. So once you prepare the data, you may need to go through several steps to prepare your data. But in this case, I just automatically generates synthetic data because synthetic data is most essential to learn how to build neural network or any machine learning model. So you can use a Keras API, which is in the TensorFlow to build your model. Here is an example of a simple feed-forward neural network. So first of all, you can define a binary classification tasks like number of classes. I have 2 number of classes, and here I have 10 shapes or features in the input. So here I have generated 10 features with 800 samples. Then build the neural network here, the modules of neural network. So in this case, I just use the Keras API. This is a simple neural network model using the Keras API, so which is a high-level API included in the TensorFlow. You don't need to separately install because the TensorFlow 2.0 supports the Keras API. Now you can use the sequential function to build your neural network model, and this initializes a sequential model, which is a linear stack of layers. So in this sequential model, you can pass the layers and the neurons or nodes in this function, and you can, for example, in the first, you can layers.dense. So this, the first parameter in the dense function is the number of neurons. So in this case, I have specified 64 units or neurons in these layers, and also activation functions. I just specified the activation function. In this activation function, I just use relu. Relu is one of the activation function. And Then the input shape is, I have already defined the input shape, which is I have the shape is the number of features I have in the data set. So here I have provided 10 input shapes or features in this layer. And also there is another layer. This is called hidden layer. So here I also provided 64 as neurons, because I have 64 number of neurons in the first layer, and the hidden layer is also has the activation function, which is relu. So the dense, basically it is fully connected layer to the model of 64 units or neurons. So the activation function relu argument specifies the rectified linear unit activation function for this layer. And the third layer is this output layer. This is the output layer. So the output is the number of classes we provided. So here that we have two classes. So the output is 2. So because that is the number of classes, it is a binary classification task. So this argument added the output layer to the model. I have 3 layers in this case: the input layer, the hidden layer, and the last is the output layers. So neural network is constructed like input layer, hidden layer, and output layer. The output layer is has 2 number of classes or binary classes, and the input layer in this case has 64, and the hidden layer also 64 neurons. So each neurons are connected with activation function that is relu. So the shape of the input is 10 features. So we can apply weights for each activation functions. Now in the output layer, I also apply activation function, which is softmax. So the softmax argument applies this function, which is commonly used for multi-class classification tasks, because I have 2 classes. This is called a multi-class neural networks, and it converts the raw scores into probability values for each class. Okay, now I have just finished the constructing or building the models, neural network models, with 3 layers. The first layer is 64 neurons. The second layer or hidden layer is 64 neurons, and the output layer is 2 classes. Okay, and we go to the fifth step. Once we build the model, we can compile your model. Okay, you can specify the loss function, optimizer, and any matrices you want to track during training. So you can use model.compile. Here I already defined the model, and you can compile with optimizer algorithm. The optimizer algorithm in this example is Adam optimizer algorithm, which is an extension of the stochastic gradient descent method. So Adam is known for its efficiency and performance on wide range of deep learning tasks. And there's also a loss function. So we can use different loss functions, but here I have classes. So I just use a sparse categorical cross entropy. You can also use mean score error. You can use different, but it depends on the data you have. So here I have a classification based data. Based on that classification based data, I just specify the loss function, which is sparse, categorical, and cross entropy. And I also specify the metrics which are going to evaluate the model's performance, that is accuracy. In this case, I just evaluate the metrics to be accuracy to monitor the proportion of correct predictions during training and testing. Okay, then we go to the 6th step. The 6th step is fit the model to your data. Once you compile the model and you go to fit the model to the data, here I have train test data. And this train test data, I just specify the X train, Y train to this model, and the number of approaches in this fit function, batch sizes also, and also validation data as a parameters, X val and Y val. I already generated in the second steps of this tutorial. So this epoch specifies the number of times the model will iterate over the entire training data, which is, for example, I specified 5. So this training data going to iterate over 5 times. So one epoch is one complete pass through the entire data set. And this is the batch size. I specified, for example, 32. This parameter basically determines the number of samples that will be used in each iteration during training. So the training data is divided into the batches. For example, the training data can be divided into 32 batches for each iterations of the epoch. So the training data is divided into batches and the model is updated after each batch. And the other parameter is validation data. This specifies the validation data such as futures and labels on which the model's performance is evaluated after each import. Then we go to the seventh step that's going to once train the model to the data, and you can evaluate your model, the performance of your model. When the model is trained, you can evaluate the performance on the test data. So you can find by using model.evaluate, x-test and y-test, and you can test the accuracy. For example, the accuracy is 50% and the loss function is 69. So in this case, it is the loss function is higher than the test accuracy. So you can, this is just demonstration. So you can really redefine the model's parameters to increase the accuracy of the model in the real-world applications. Okay, then we can test our models by make a prediction. So use the training model to make a predictions on unseen data. Let's generate 5 sample data with each 10 futures. I have already 10 futures in the training data, so I can make a prediction on the test or a new data. So this is the predictions. I have 2 classes and each classes can be predicted in with 10 futures and 5 sample data. So this is the prediction, the output of the unseen data. And now we can save the model once we make sure that the model is good enough, and we can save the model for later use. So you can use model.save, model name.h5. This is the architecture of neural networks, especially in TensorFlow. So it just saves to in the name of my model.h7, and you can load this model anytime you wanna make a predictions in the new data. So that is a good thing. So basically this saved in the HDF5 file format with the file name, for example, my model. And this allows us to save the trained model architecture, weights, and the training configurations we have applied to train the model, neural network model, and which enabling us to reuse the models later or share it with others. So this is a basic overview of how to train a neural network using TensorFlow and Keras in Python. I hope this video or tutorial was useful, and don't forget to like, share, and subscribe. Thanks for watching today.